Morning, Trig. We're going to cover a really fast and easy lesson. Should only take a couple minutes. So this is on combinations. So there are two things we look at, permutations and combinations. And the important part here is permutations are for things where the, this should say, hold on. Permutations, sorry, I caught myself a little typo. Permutations are for things where order matters, like, for example, passwords, names, a locker combo, zip codes, telephone numbers, right? Those things, the order matters in which we enter them. Combinations is a selection of items where the order does not matter. For example, it doesn't matter the order that your numbers are selected for the lottery. Doesn't matter what order I select my cards when I'm playing poker. It doesn't matter if I got the king first and then the ace. Doesn't matter. Or, for example, a committee of people. No one is above the other, so it doesn't matter the order in which we select them. So just being able to know the difference between the two and when to use a permutation versus a combination. So in your calculator or Desmos, you should have NCR. If you don't have a calculator, you would need to use the following formula. But N is your total, and R is the objects selected, or items selected, or however you want to word that. So number one, in how many ways can a committee of 5 students be selected from 12 students? So I told you above, committees, the order does not matter. And so I would simply, there are 12 students, then I would select the NCR button, then hit 5, and then hit enter. Now, for that, you should get 792. Now, if you don't have that button or a calculator near you, you would have to do 12 factorial divided by 12 minus 5 factorial times 5 factorial. And we've gone over how, whoops, I set this. Man, I'm making all kinds of mistakes. This should look like this. And you could do that by hand, or at least part of it, right? 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 factorial. So one of the 5 factorials would cancel. 12, this should be 5. And this is, I knew I did something wrong. Man, I'm just making mistakes left and right. 7 factorial would cancel the 7 factorial, and then I would have 5 times 4 times 3 times 2. So you could do it by hand. 10 would take out the 5 and the 2. 12 would take out the 4 and the 3, and you'd be left with 11 times 9 times 8, which is 792. So up to you. I would be preferable, right, to have a calculator. So if you'd like to see it, you would hit 12 first, then probability. It's under probability, so you'll find this under probability. Okay, and you go over to it, then hit 5, and then enter. Okay. Number 2, there are 7 points on a circle. How many different triangles can be drawn, right? 1, 2, 3, 4, 5, 6, 7. And it doesn't matter the order in which I draw them, which is why it's a combination. So 7, there are 7 points. And how many does it take to form a triangle? It takes 3 points for a triangle. So that is why it would be 7C3. So 7, probability 3, and I got 35. How many different 5-card hands are possible from a standard deck? In a standard deck, there are 52 cards. So 52, and I'm choosing 5. Remember, I told you cards, the order doesn't matter. So 52, probability, 5, 2,598,960. That's the different number of hands you could draw or be dealt. 2 more. How many 5-card hands contain 3 hearts or 2 spades? All right, so let's talk about, there are 13 hearts, there are 13 diamonds, there are 13 clubs, and there are 13 spades. So I want 13 hearts. There are 13 hearts, sorry, and they're asking what's the probability of 3 of them, or how many, sorry, not probability. And then there are 13 spades, and we're choosing 2 of those. And so in this case, you have 2, 13 C3 times 13 C2, and I get 22,308. Last one, how many 5-card hands contain 4 kings? Well, there are only 4 kings in a deck, right? So there are 4 kings, you're choosing 4. Times, you still have 5 cards in your hand. So 52 cards minus the 4 kings is 48. So there are 48 cards that are not kings. And you're going to have 1 of them because you still need 5 cards in your hand. So 4 C4 times 48 1. And I get that there are only 48 hands that contain 4 kings. All right, so for homework for lesson 75, you're going to skip numbers 1 through 4, 15, 23, and 24. Thank you.